Bergson and the Holographic Theory of Mind. Continuing on, a look at Chalmers' book, Reality Plus, or shall we say, in his view of virtuality, that we all live inside of a PC, and the actuality of the book, it's a bit of a conceptual disaster zone, in my opinion. For a solution to the hard problem, philosophy is utterly flummoxed. To me, seriously considering that our reality is actually a virtual world, a digital world, created by some mysterious computer somewhere, that we are all virtual characters in this, quote, game, unquote, can only be a measure of the level of the flummox. But yes, that's what we're now looking at. How did we get here? There's one small footnote in the book on Bergson, on virtuality as related to actualization. End of look at Bergson. Time is mentioned half a dozen times, totally inconsequentially. The complete disdain for the problem of time. This is how we got here. The sad unawareness of the classic metaphysic of space and time underlying all of their thought. This is how we got here. In Chapter 8, we are treated to a discussion of the Wigner's it from bit concept, namely that the physical universe, the it, derives from information, that is bits. Chalmers is well aware that all bits are abstractions which only exist over a concrete embodiment, say voltages. As I've noted before, here's one bit on a breadboard, what it takes, the transistors and switches needed, or even in the Stone Age version, the magnetic cores. That is, bits don't exist without physical embodiment, some physical concrete way of representing them. This does not stop him. Chapter 9 asks this question: why should the interaction of bits bring atoms and molecules into existence? His approach is to invert things, to use the simulation hypothesis itself to explain what this could be. To quote, suppose the simulation hypothesis is true, then the simulation involves a system of bits. Our experiences are produced by an algorithm involving a pattern of bits that simulate a standard physics with quarks, electrons, and so on. Continuing, this pattern is itself a system of digital physics. Important, digital physics, with bits obeying digital laws. In a perfect simulation, the mathematical structure of the photons can be recovered from the mathematical structure of the underlying digital objects. Okay, well, not okay, but he goes on. Now comes the crucial step. If we can recover the mathematical structure of standard physics from digital physics, and if digital physics produces our observations, then digital physics realizes standard physics. That is, digital physics makes the quarks and electrons of standard physics real. To go on, importantly, if the simulation hypothesis is true, our observations of electrons and quarks are produced by certain patterns of bits. If these patterns of bits underlie the mathematical structure of photons in our world and also produce our observations, then those patterns realize photons. By arranging the bits of digital physics in the right structure, the simulator has thereby created the entities, the its, the physical things of standard physics. In this way, the simulation hypothesis leads to the it from bit creation hypothesis. So if the simulation thingy is true, so here we go. On simulating the brain simulation is a digital system running on a computer. If we can establish that one digital system is conscious, then we know there's no general reason why digital systems cannot be conscious, and the floodgates will open. He's happy about that. How would simulating a brain work? We can suppose that every neuron is simulated perfectly, as is every glial cell and other cells throughout the brain. The interactions between neurons are simulated perfectly too. All chemical activity is simulated. Keep in mind, for example, he's going to remove a neuron physically from the brain and simulate it on a computer. And he would connect the input and output of that neuron to the computer, and then of course then that neuron is running on the computer and the rest of the brain is running physically. That's the idea. But note that all electrochemical activity is simulated. What? I mean, he's kidding. Again, a digital simulation does not light one Christmas light. You need a real concrete dynamics. But his dynamics are only abstract operations, just a Turing machine. The Turing machine, running its tape, from square to square on a tape, is not going to light that set of lights. But yes, a concrete field, some electromagnetic fields generated by a DC motor with all of its physical characteristics will. This is an incredible lapse or slip of logic, shall we say. He's slipping this by, but he pushes on. Here I'm assuming that the brain is a physical system and therefore obeys laws that can be computationally simulated. Certainly current evidence favors both these assumptions. Okay. These assumptions do not guarantee that a neuron-level simulation will work. Perhaps to simulate brain processes really well, one will have to go down to the level of physics. We'll proceed in stages, he says. We'll build a simulation of each cell and arrange for it to interact on the brain, in the computer, via receptors and effectors with neighboring biological cells. Eventually, a quarter of your brain will be simulated. So we can get rid of a quarter of the brain. It's running on the computer. Then half. Then 3/4. Until the result is a fully simulated brain. Perhaps the simulation will be connected by effectors to the original physical body. Or perhaps the body will be simulated too. Consider a couple earlier statements. Consciousness was, this is like in context of his leaving physics and coming into the subject of consciousness. Consciousness was the most familiar thing in the world, but also the thing we understood the least. How did it fit in the physical world? In the physical world, how could there be subjective experience in an objective world? No one knew. Continuing, why should brain processes give rise to conscious experience? Why don't they just go on in the dark without any subjective experience at all? No one knows. What changed in the above? That is, how does simulating the brain's neural processes solve this problem? Why does simulating the brain's neural processes tell us anything more about how these processes bring about the image of the external world, our experience? Said I, what am I missing here? What is Chalmers thinking? Well, I answer my own question. I realize, yes, he thinks he has simulated everything about the brain and its neural processes. Thus, somehow, that is everything. Notice that if he had to, he'd go down to the atom level. So, thus, somehow he has to have captured in his mind what makes the brain work. That's how we see the coffee cup out there. But he is assuming, again, the brain's physical dynamics can be simulated digitally, that he knows what these dynamics actually are. Remember, he thinks he can simulate electromagnetism. That is, his simulation can light up Christmas lights. Yet we're not clear how that's possibly the case. That one just slipped by. But that's where he's coming from. He's captured everything, therefore he's going to capture perception, conscious perception as well. So sorry, there my head was spinning from all the problems that are actually sitting here, including the thing he slipped by. So in chapter 20, we find Chalmers taking up an issue with Dennett. For Dennett, a simulated hurricane doesn't make you wet. And a Turing machine does not run one Christmas light. Same thing, same principle, same critique. Says Chalmers, so Dennett's slogan is at best half true. If we're outside a simulation, then a simulated hurricane won't get us wet. But suppose we're inside a simulation and have been for our whole lives. In this case, a simulated hurricane can certainly get us wet. If we're in a lifelong simulation, then all the hurricanes we've ever experienced have been digital hurricanes. Even Hurricane Katrina was a digital hurricane. So being inside a simulation, this is critical. A critical ingredient in how the brain architecture is accounting for our experience of the external world in his mind. Apparently, it even creates an electromagnetic field and lights up Christmas lights, as we saw. To which Tesla says, amazing. In other words, that we are a simulation. So let's see. So here I am sitting in a virtual reality. Well, actually, this is the famous picture self-drawn by Helmholtz. We'll just change it to me, not the Helmholtz. So it's a nicely specified world. I don't see my head. This is literally Douglas Harding's on Having No Head, favorite little book of mine. It's all being generated by that mysterious digital computer. This is my virtual reality here. First of all, I wonder, why do I need a brain? Note again, it's all being generated by that mysterious digital computer. If I'm in a virtual world, that world's being specified by the computer. Virtual reality does not need a brain. No more than Kastrup's idealism, we're always created by the mind, but that which is, TWE, needs a brain. So, in other words, Chalmers' brain simulation exercise is kind of a waste of time, unneeded. Maybe also why deep down he's apparently not worried how the brain or his simulation accounts for the experience, for the coffee cup out there. But now let's add some dynamics. Let's put time in the picture. Stir that cup. So adding time. Now let us remember, this experience is all being generated by a digital computer. That is by a Turing machine. Same difference. Turing machines should work just as well as any computer. That is, this computer is proceeding state to state to state. Each state disappearing, each instant disappearing as the present state arrives. So where is the source of continuity? Allowing the experience to be time extended, to have a duration. There's a time extended experience right there. How did we get that? From a Turing machine. Well, let me tell us. Chalmers is assuming the indivisible transformation of the universal field. He is assuming surreptitiously Bergson's temporal metaphysic. He is assuming the consciousness that is supported by this indivisible motion. Chalmers is totally unconscious with respect to the classic metaphysic of space and time beneath his thought and its logical implications. So much so, this surreptitious, gratuitous assumption of an underlying continuity, not acknowledging the instantly disappearing instants that states entailed by his metaphysic, utterly passes him by. Again, the classic metaphysic, an abstract 4D space of points, positions / instants. A space is infinitely divisible. Each point, an instant of time. When I move that spoon across the continuum, tracing a series of points across the continuum of points positions, each point corresponds to an instant of time. That instant corresponds to an instant taken across the entirety of space. It's a mathematical instant, it's an extent, a time extent, because we're talking infinite divisibility of this continuum. And if we could end the operation of infinite division, we'd end at a mathematical point. That would be the duration of any instant, of any of those cubes of space. All these instants then fall into the past, one by one, into non-existence. Only the present instant exists. And that is defined as matter. It has to be so by definition, because all the other instants have fallen into non-existence, but matter exists. So in this framework, there can be no extended duration of neural processes, no continuity, no stirring spoons. When we're in a virtual reality game, it is our consciousness which is integrally participating in the indivisible transformation of the matter field that is providing the continuity. That's allowing the perception in the game of stirring spoons, or revolving planets in this case. So Chalmers' argumentative scheme, IMO, looks as such. He sort of starts from it from bit. But bits are abstract. They need a physical substrate, and it. So we've got a circularity. That is, we need the physical for the bit, but supposedly they're abstract. How do you avoid this? Well, via brain simulation, via bits, which creates reality, that is virtual. So all reality is virtual. Thus, it from bit. It's quite happy. But we've seen this linchpin is, particular one, this one, is easily destroyed just via simple considerations of concrete time versus the abstract time of instance of the computational model. That is the classic metaphysic in which this whole argument lives, unbeknownst to him, apparently. His still having no model of the brain that accounts for experience. The coffee cup out there. That is, just because he simulated every single atom of it doesn't mean he understands how it happened at all. That's just sort of disappears somewhere and evaporates in the book somewhere. I mean, into the etheric. The true nature of time or duration as an indivisible flow is also at the bottom as never being able to simulate, never simulating electromagnetic flux. That is, somewhere in this argument flow here is the I'm in the simulation versus not in it. We're outside the simulation. But again, even that, that falls apart from the same thing. So all of this is related to the unreality and insufficiency of physical and its mathematical law. Yes, even quantum mechanics psi, to fully express the concrete time transformations of the matter field. We discussed that, note the video numbers there. So it from bit. This concept is supported in Chalmers' thinking by two things. That there can exist a digital physics where all physics laws have an underlying digital form. And structuralism in physics, where structuralism, he says that mass is defined by these mathematical, take the law of F equal ma, and observational roles. As is sometimes put, mass is what plays the mass role. So in other words, mass never gets outside of the physics equation. That's all there is to it. Now going deeper into structuralism is not important here. Implicit is the nicety for the simulation thing, namely, there exists a set of mathematical laws that the simulated computer, that is digital, can use to create the material world. Whether or not we can turn these laws into, well, that's important to him that they get turned into digital laws. In other words, these laws are just abstract entities, independently of the human mind. Pretty much Platonic forms. We saw in Bergson's long discussion in Creative Evolution, his discussion of the nature of mathematical law, that these laws have no positive reality. To quote him, it is merely this negative tendency that the particular laws of the physical world express. None of them, taken separately, has objective reality. Now, we don't have to go into 49 by what he means by the negative tendency. Very briefly, it's in Bergson's model, the physical is coming from the consciousness, from the internal, from the intensive. The extended world is always deriving, always coming forth from the intensive. But it's simply a negative tendency, a lessening of the intensive into the extensive. Check that in 49. The point being here, none of these laws taken separately has an objective reality. He noted that each law is the work of an investigator who isolated certain variables, worked from a certain bias, applied conventional units of measurement. And, quote, measuring is wholly a human operation, which implies that really, or ideally, we superpose two objects, one on another, a certain number of times. So, for example, his example was, supposing we want to determine the law of boiling. Well, basically, we're effectively taking boiling the pot yesterday and superimposing it on boiling of today. And then we might superimpose that again on a boiling tomorrow, or make the time scale smaller, an hour by hour by hour. But basically superposing objects in time one on another a certain number of times. Nature, he says, did not dream this superposition. And we're superimposing qualities as if these were magnitudes. By magnitudes, that is lengths, shall we say, treated by math. But what is the coincidence of two qualities? Say the aroma, the clinking, the form of the flow field, the feeling of stirring, the bubbling. How are they identical? For Bergson, our inductions, and this is an inductive process, are certain, and the exact degree in which we make qualitative differences melt into the homogeneity of the space which subtends them, that is, to that abstract space. So that geometry is the ideal limit of our inductions as well as our deductions. I emphasize ideal limit. It's a limit that's never reached. And therefore, these laws do not ever actually exist objectively. Physics is relative to the variables it has chosen, even the order of the problems examined. Put differently, these laws are anthropomorphic. And if one thinks Bergson was alone, we kind of ask, is there a law of entropy that Chalmers simulation will employ to generate its world? We wouldn't want this type of event to happen in our simulation, would we? The cup reassembling is not following the normal physical laws of the world. Or virtuality would be, well, quite different. But is there such a law? Well, not really. This was the subject of a famous paper by Jaynes on entropy. To quote Jaynes, it may come as a shock to realize that, nevertheless, thermodynamics knows of no such concept as the, quote, entropy of a physical system, quote. A given physical system corresponds to many thermodynamic systems. Take a look at this for a second. He says, consider, for example, a crystal of a shell, salt. For one set of experiments on it, we work with temperature, pressure, and volume. The entropy can be expressed as some function, S sub entropy, T of P, that is a function of temperature and pressure. For another set of experiments on the same crystal, we work with temperature, the component E sub xy of the strain tensor, and the component P of X or P of Z of the electric polarization. The entropy we found in these experiments is a function of, have it there, SOT, EX of Y, P of Z. It is clearly meaningless to ask, what is the entropy of the crystal? Unless we first specify this set of parameters which define its thermodynamic state. Okay. He goes on, one might reply that in each of the experiments cited, we have used only part of the degrees of freedom of the system, and there is a true entropy, which is a function of all these parameters simultaneously. However, we can always introduce as many new degrees of freedom as we please. For example, we might expand each element of the strain tensor in a complete orthogonal set of functions, such and such, and by a sufficiently complicated system of levels, we could vary each of the first 1,000 expansion coefficients, A sub I k, independently. Our crystal is now the thermodynamic system of over 1,000 degrees of freedom, but we still believe that the laws of thermodynamics would hold. So the entropy must be a function of over 1,000 independent variables. There is no end to this search for the ultimate quote-unquote true entropy until we have reached the point where we control the location of each atom independently. But just at that point, the notion of entropy collapses, and we are no longer talking thermodynamics. From this, we see that entropy is an anthropomorphic concept, not only in the well-known statistical sense that it measures the extent of human ignorance as to the microstate, even at the purely phenomenological level, entropy is an anthropomorphic concept. For it is a property not of the physical system, but of the particular experiments you or I choose to perform on it. This points up still another qualification on the statement of the second law, without which it is, strictly speaking, no law at all. If we work with the thermodynamic system of n degrees of freedom, the experimental entropy is a function of S sub e, x, and x of n independent variables. But the physical system has any number of additional degrees of freedom, x of n plus 1, etc. We have to understand that these additional degrees of freedom are not to be tampered with during the experiments or on the n degrees of interest. Otherwise, we could easily produce apparent violations of the second law. Just saying that there are self-existent physical laws just waiting around to be used by a simulation, a severely questionable concept. In chapter 23, Chalmers describes the pre-theoretic world, the world before the enlightenment of today's theorist, supposedly enlightened. To quote, in Eden, everything was laid out in three-dimensional space. Space was Euclidean and not relative to anything. Things in Eden changed with the passage of time. Time flowed from moment to moment in one direction with absolute simultaneity across the garden and across the universe. In other words, he simply buys, uncritically, the endlessly repeated mythologies with respect to the meaning of special relativity in the four-dimensional space-time block in which there is no flow of time, there is no passage of time, which, by the way, if seriously employed, would make nonsensical all models of consciousness, virtual reality and not virtual reality. See the numbers there. Continuing, the apple in the garden was gloriously, perfectly, and primitively red. When we perceive the apple in its redness was simply revealed to us directly, without any mediation. Baloney. Already in 1889, Bergson trashed the primitively red bit in Time and Free Will. Just saying, just picking one theorist. Here, Dr. C is trashing direct perception as well. We saw things directly. But we have just seen, despite the enlightened break, quote unquote, from Eden, he and his compatriots have not one clue how we see the apple or the coffee cup out there with all their qualia. That is, trashing direct perception, he's hardly in a position to do so. People in Eden had free will. They could act with complete autonomy, and their actions were not predetermined. He waffles a little bit on that one, ultimately, but he tends toward it. But the current no free will enlightened position rests directly on the ever unexamined classic metaphysic of space and time, underneath their thought, as does relativity, as does the hard problem. So the enlightened ex-Edenites are led to the incredible proposition that we all live in a virtual world inside someone's PC. The former Edenites are totally disoriented as to where they now dwell. This is desperation. not enlightenment. So postscript. Just suppose Chalmers had considered Bergson's model of perception, his solution to the hard problem, been just a bit familiar with it, maybe just tried to penetrate into the meaning of that footnote with respect to Bergson and virtuality. Because there was a quite different model of virtuality. It was embedded in a holographic field, a field transforming indivisibly, with no instance, totally different from the classic metaphysic. And the brain is acting as a concrete, modulated, reconstructive wave passing through this field. Up in a little box there, holographic reconstruction, we can modulate that reconstructive wave passing through the holographic plate. Frequency 1, the cube, frequency 2, the cup, frequency 3, the wine glass, back to frequency 2, the cup, etc. So acting as a modulated reconstructive wave, but a concrete modulated reconstructive wave was concrete as the forces generated by an AC motor. The image specified right where it says it is, external within the field. And the brain's chemical dynamics underlying this wave, specifying is specific to a scale of time. Our fly buzzing at normal scale, 200 wing beats per second, seen as a blur. Change the energy state underlying that wave. A heron-like fly, barely flapping his wings. Raise the energy state even more. The fly becomes an ensemble of electrons, a whirl of electrons. Concrete dynamics are important. And that cup, the stirring, as we noted, an invariant structure. Invariance over time, defined only over time, driving the brain's modulation pattern. What would he have been then? What would he have then been, shall we say? Would he have been then, shall we say, so incautious in his, quote, the brain and perception can be simulated by a digital computer, thesis? So disdainful of actual physical dynamics. Maybe a teeny-weeny second thought. Just a wistful wondering. Next we'll see. Till then, signing off.